Well, it's a beautiful day. The sun is shining. The first false spring is here, and I am really excited to get going on this build. But before we do that, I'd like to thank everybody who subscribed so far. And if you haven't already, please be sure to do so now. I really appreciate it. We are inching painfully closer to that 1,000 subscriber mark. So I would really be happy if we could get over that. With this video, that would be tremendous. So please, like I said, like, subscribe. If you know anybody who might be interested in this type of video, please share as well. So let's get started. Well, as I had mentioned, all of our parts have arrived, and that is good timing because now we can actually start to fabricate our drive system for the personal track vehicle. We have our motor mount plates, we have our drive hubs, and all of this is going to come together to actually make a fully integrated drive system with the motors built right into the tracks. So we're going to get set up with some sawhorses, get the undercarriage on there, and today's mission is to get both of these track undercarriages set up with the motors. Ideally, if we could get them 100% complete, so that all we need to do the next time we're touching them is connecting some hydraulic hoses and putting them onto the chassis of the vehicle. So let's get started on that and not waste any time here. Well, we got the cross member cut out, and we've got our new motor drive plate installed. Next step is to get that welded into place on the top, the sides, and flip the whole undercarriage upside down, weld underneath, and this should be ready to go. We'll do the same on the other one, and that'll be the motor mounts complete. There we go. We have our track drive motors installed. That worked out quite nice. So like I said, these holes are elongated so that we can move the motor back and forth to tension that chain. That means that we're not going to need an idler. Now, an idler won't work very well with this type of configuration because you usually want an idler to be on the slack side of a drive chain. Now, with this type of a track drive going forward or back, there really is no slack side. Both will be under load at some point in operation. So if you can avoid an idler, go straight to a proper tensioning arrangement like this, that's going to be way better. So we've got this done. The motors are just temporarily bolted into place, as you can see. But the next step in the process is going to be cleaning up this tube here. We're going to cut a piece of that rectangular tube, and we're going to extend it out to where we want that front bearing for the drive shaft to be now. So a quick explanation on what I'm doing here. I just have this piece of 7/8 rod mocking up that drive shaft with these wheels on it. And what I was trying to do is just measure the distance between the bearing tube and this front tube here. So basically the distance from here to here that we're going to cut that piece of 3-inch rectangular tube, so I figured it's going to be around 4.5 inches. We will just do a little test fit, so we'll just tack everything together with 4.5 inches. The tricky thing is that there is some tensioning built into the track subframe here. If you get that measurement there too long, you're going to have a pain in the ass getting the track on. If it's too short, you'll get the track on easily, but you're going to run out of tensioner and you will never get the track to the right tension, and it'll be slipping and give you a pain in the butt. So there is a middle ground there that you have to strike, and we're going to tinker with that. Once we get it figured out on one, it'll be identical for the other one, but this is kind of a critical step here. Well, let's take a look at what I've got here so far. This is the second tube that I have cut. The first one was 5 inches long. This one is 6 inches long. So you can see how it's kind of just temporarily held in place there. The jack stands are just kind of holding it from rolling down. But we'll take care of that issue later. Once it's all welded, it'll stay exactly as it is. So I've got it tensioned fairly close to where it would be for operating, and you can see that we have a little bit of room left on that tensioner, which is pretty good. I am contemplating extending that tube by 1/2 inch just so that we can give ourselves a little bit more adjustability there. I don't think that will be too much of an issue getting everything into the tracks. It should all work out fairly well, but overall, this is how everything is going to line up and work out. So I'm quite pleased with how this is looking so far. We're going to keep going, and like I said, I'm going to cut a tube like that, maybe 1/2 inch longer, and we're going to start to actually get this put together. All right, so what I was doing inside the track there down on the floor is just making sure that I got the spacing between the outer track sprockets, the inner track sprocket, and our chain drive sprocket, so that this bearing tube is in the right location as far as left to right. So what I came up with there is that arrangement, we need this to be just slightly offset. So from the outside of this tube here to the center of the track needs to be 2 inches. So that's what I measured and marked, and this tube is just slightly offset, so it gives me a little bit more space to weld around here and get it all set up. So we've got that figured out now. What I'll do is tack weld this in place, and then we can actually do a real mock-up of the undercarriage in the track and make sure it all lines up nice. Okay, so what I'm doing here is I want to make sure that this drive shaft is basically true to the track. So I just put a couple pieces of the actual aluminum rod that goes in there, and we have our drive axle just sitting in there temporarily. So what we want to do is make sure that both of those are parallel so that the drive track isn't skewed one way or the other. And we also want to come to this side here and make sure that our drive our drive shaft is in line. And so it's very difficult to see with the camera here, but I've got both of these, I would say, as close to parallel as possible. So that's what we want. I'm going to go ahead and get this kind of tacked together, a little more than tacked together, just so that it doesn't move around when we start to play with the tracks, and see how it all comes together now. Let's take a look at what we have here. So that support tube is welded up, not permanently, but I'd say about 20% now. And I've got the mock-up axle in there. I'm using a 7/8 axle just because it's easy to slip the drive cogs and everything on and off. When we get to the 1-inch, I'm gonna have to press those on, and it'll be a real pain in the butt to get them on and off after. So for mock-up purposes, it just makes things way easier using a little bit smaller. That 1/8 of an inch really doesn't make any difference when it comes to the final measurements. So we've got the track somewhat tensioned right now. We've got our motor in place, and you can see now what we have going on for drive sprocket setup. So inside we have our driven sprocket. On the motor we have our drive sprocket, and you can see we have pretty good clearance. I might need to reduce this diameter a little bit. I'm just worried about a little bit of rubbing going on here. If we bring that size down, we bring even that size down a little bit, we should be okay. I just wanted to leave maximum adjustability. I may want to overdrive these motors a little bit. For this size of vehicle, I might not need all the torque that I had for the Mini Snowcat. So overdriving these would mean that I get a little bit more top speed. The sacrifice is losing out on a little bit of torque, but again, I don't think I need as much torque as I did for that Snowcat. This machine is going to be probably, I'm going to say about a quarter the weight of that other machine, and yeah, we'll be in a much better position with this pump and motor combination. So the next step, now that we've got this all kind of working out really nicely, is to go ahead and add some supports in there, just to kind of triangulate that down to the lower axle where these wheels are actually sitting. Once we've got that done, we could go ahead, weld everything up, and we will be done with the fabrication for the bearing and the support. We'll do the same on the other track over there. We will get it mocked up basically to the same state as this one. We've got everything welded up. It's still ripping hot, so we're going to let that cool down for a while. But overall, the front front mount for the drive shafts are done. We're going to let them cool. And while we let them cool, we are going to move on to the next part of this stage in the build, and that will be getting these drive sprockets ready to actually mount onto the key shaft. So as I had pointed out previously, the plates that I had cut have a key in them, and so we just need to do a little bit of cleaning up with the file. They're pretty much ready to go. There's not much that is really needed, but just to tidy them up a little bit, and then we are going to start getting these set up in such a way that all of these drive sprockets are clocked appropriately to this keyway, so that they all line up in time, as you can see here, between all of the drive lugs on the track. So what we'll do is we'll get these cleaned up. We will put the piece of key shaft into the vise here, and we're actually just going to line them all up, try and get them all aligned. So I just want to show you what I'm cleaning up here in these cutouts. So this little piece here, that little ridge where it started the cut and went all the way around and ended, that I just have to take down with a file. The other thing I have to do is the corner where the little keyway ends, the radius of the actual laser, where it actually goes in there, is not quite clean and perfect enough. So I just use this little file to get right into that gap there and to clean that up nice and smooth, so that it slides onto the key shaft. And this is what we end up with. This little plate here just glides so nicely along that shaft. It interlocks perfectly. And so that is what we're going to use for driving those sprockets. Let's take a look at what we have here for the drive setup. So we have our sprocket on the shaft. I just hammered it on. It's a tight fit, but it keeps it nice and square on there, so we don't have to worry about it kind of wobbling or anything like that. I have our cut plate here, so that's basically just going to go right up to there. And then all we're going to do is drill these out and use some 1/4 inch little carriage bolts to hold that in place, and we should be good to go. So far this is working out pretty good. In hindsight, I hadn't really considered where these holes would line up with the spline on the back side. So most of them clear fairly well. This one here lands right in the middle of the spline. The other two almost land perfectly on the splines as well. So right here I've got, what's that, 1, 2, 3, 4, 5, 6 out of 8. I think that'll be plenty for what we are doing here. Like I said, hindsight 2020 would have made things a lot easier if I had just planned to navigate around those. Okay, so we got all of these plates mounted up, and that part is done. The next step, we are going to start to get the front drive axle assembled. So we'll get these sprockets kind of mounted into place where they need to be. We will also work on the drive sprocket, the chain drive sprocket that's going to go up front here, and get that into place. We can start, once we get all these sprockets in place, start getting the chain in place, cut to length, and then we can get the tracks on these things. With a little monkeying around, we managed to get the drive line set up. So I have a little spacer in here. This is where that drive sprocket needs to be. Now I chose a smaller sprocket because like I said before, I wanted to make sure the chain clears this part here. So having the smaller sprocket up front is not a bad thing. We could always go to an equivalent sized sprocket on the motor. We can go bigger, we could go smaller, we can kind of adjust it as required without having to take this front end apart. And that just makes it a little bit more, user-friendly, I guess. So yeah, this is coming together really nicely. So it's at the point now where I am gonna give it a shot. We're gonna try and put it into the track and see how it fits, get it tensioned up, see how it rolls, and if that's all good, what we will do is cut a couple little spacers here just to keep this all spaced equally, just a piece of pipe that will thread over or put over the drive shaft to keep everything in place. These are all really snug actually, so I'm not really worried about them walking around too much, but I just want to be certain that we don't have any issues. It works. It fits perfectly. Sprockets are spaced out perfectly. This is going to be fantastic. I am very happy how this all went together. And basically we know that once we get all those spacers cut, we can get this assembled and then we'll be good to go. So I'm going to take this off. Interesting piece of information: when I was wrestling the track onto the undercarriage, you would think that you would, like I started, have the track laying down and then drop the undercarriage into it. Well, it actually makes more sense, or it's a little easier to leave the undercarriage and then try and work the track down over top of the wheels and everything, and you can kind of move it around as you go, and it actually works out a lot easier. So having said that, let's take the track off again and put this together for the final time. There we go. The drive line is assembled. It is ready to go. We have spacer there. This worked out nice. Another spacer there. Nothing there. I don't think that's going to be too big of an issue. And then we have collets on the outside. So we have the exact same setup on the other side here. The next step is going to be, you saw me weld those together, the sprockets for the drive motors. So we're going to tackle the drive motors next. Before we do anything else, we are going to get some fittings installed so that we go from NPT, National Pipe Taper 2 flared fitting. Flared fittings are far superior for connecting and disconnecting. So once we get that done, it'll be a lot easier to get some hoses with some little elbows on to come out and make some nice liquid tight fittings there. So once we get those on, we'll get the motors bolted in place. We will get our sprockets onto the motor, and we will cut some chain to length, get those tensioned, and these will be done. Okay, so I've got some NPT fittings in here. They've got some Teflon tape on them. We will use the torque wrench to get these tight. So the thing with the NPT is if you can turn it, it's not tight enough. So you need to keep going on these until basically you cannot turn. What I was saying is you need to turn these until you can't, and then go another half turn just to make sure that they are fully seated, and then these fittings will never have to come out again. Oh my goodness, I am exhausted. This has been a lot of work today. It's basically been a full 8-hour day so far, but the end is near. We have our motors mounted, we have the chains set up, everything's ready to go. So basically these are how I want them to be, and the next step, the last step for this video, is to get both of these into the tracks so that we can continue on with the build. But for the most part, the tracks will be done. Well, there we have it. The tracks are complete. I've got the track onto the undercarriage, and it is tensioned. It is ready to go. I added a little bit of grease to these threaded bolts down here so that they can travel nice and smooth. And yeah, so like I said, there is nothing else to do on these. These are complete. The next step will be attaching them to the machine chassis and connecting up pair of hoses down here, but otherwise, yeah, there's nothing else really to do with them. They turned out fantastic. This is way cool, actually. I'm very pleased with the setup overall. You can see there's our motor in there driving our sprocket up front. So everything turned out really nice. I'm very pleased with the overall fitment, and yeah. Like I said, that's it for this one. So the next one, we're gonna start building the chassis and getting the engine and pumps mounted, and this should be going pretty quick, actually. I think we tackled the hardest part of the whole build. This was a lot of work. Like I said, this was a full 8-hour day to get it all this fitted together, but overall it turned out pretty darn good. So I'm gonna leave it there. Thanks for watching, and we will see you on the next one.